I was just reading the latest clinical data on myelin degradation, and it changes how we should evaluate processing speed decline in healthy aging adult populations. Many people notice a subtle but persistent slowing in their mental reflexes as they grow older, assuming it is an early sign of memory loss as we navigate healthy aging during daily cognitive tasks. We commonly treat this delay as a failure to recall information without considering the physical conduction velocity of the signals themselves in our daily lives to protect our brain structure. However, neuroscience suggests that this slower processing speed may relate specifically to age-related changes in the myelin sheaths that insulate our neural pathways within neural tissues as we navigate healthy aging. Imagine a system of high-speed communication cables, where the protective outer insulation begins to wear thin, slowing down the transfer of data under these metabolic conditions in our daily lives. We are exploring how myelin degradation affects signal transmission, helping to reframe slower thinking from a memory problem to a structural insulation change to support cognitive endurance within neural tissues. When myelin integrity declines, the action potentials traveling along axons experience significant signal leakage and slower propagation speeds as we age over time under these metabolic conditions. If we try to address this slowing only by practicing memory drills, we ignore the physical pathways that carry those signals in healthy adult populations to support cognitive endurance. The stakes are high because white matter degradation is associated with reduced cognitive flexibility, slower coordination, and accelerated brain aging for long-term health span as we age over time. Understanding the physical pathways of myelin maintenance allows us to investigate practical low-risk protocols that support our brain health naturally during daily cognitive tasks in healthy adult populations. The problem is that myelin degradation occurs gradually throughout the brain, making its early structural impacts difficult to identify in daily life to protect our brain structure for long-term health span. By identifying the specific cellular mechanisms of white matter aging, we can establish better daily protocols to support cognitive longevity as we navigate healthy aging during daily cognitive tasks. To understand this structural process, we must define myelin, a lipid-rich substance that forms an insulating sheath around nerve fibers in our daily lives to protect our brain structure. This insulation is produced by oligodendrocytes, specialized glial cells that wrap their membranes around axons in the central nervous system within neural tissues as we navigate healthy aging. The primary function of the myelin sheath is to facilitate saltatory conduction, allowing electrical signals to hop rapidly between gaps in the sheath under these metabolic conditions in our daily lives. These gaps, known as nodes of Ranvier, contain high concentrations of ion channels that regenerate the action potential as it travels to support cognitive endurance within neural tissues. This saltatory conduction increases signal transmission speed by up to 100 times compared to unmyelinated fibers in the tissue as we age over time under these metabolic conditions. The brain's white matter consists of these myelinated axons, coordinating communication between distant cortical regions during complex cognitive tasks in healthy adult populations to support cognitive endurance. Once inside, signal coordination depends on the precise timing of arrivals, which requires uniform conduction speeds across all participating pathways for long-term health span as we age over time. During healthy aging, changes in oligodendrocyte function or lipid composition can gradually reduce the thickness and integrity of these sheaths during daily cognitive tasks in healthy adult populations. As we age, metabolic changes can reduce the regenerative capacity of oligodendrocyte precursor cells in the brain tissue to protect our brain structure for long-term health span. This reduction in precursor cells limits the brain's ability to repair microdamage to the myelin sheath caused by oxidative stress as we navigate healthy aging during daily cognitive tasks. When myelin repair is insufficient, The sheaths show progressive structural changes, including ballooning, splitting, and overall thinning of the layers in our daily lives to protect our brain structure. Thinning myelin sheaths allow potassium ions to leak out of the axon, reducing the efficiency of the action potential propagation within neural tissues as we navigate healthy aging. This ion leakage slows down the signal conduction velocity, causing a delay in the arrival of information at the synapse under these metabolic conditions in our daily lives. Because cognitive tasks require the synchronized activation of multiple distant brain regions, even microsecond delays can disrupt network coordination to support cognitive endurance within neural tissues. The prefrontal cortex and corpus callosum are particularly rich in myelinated fibers and show high sensitivity to these age-related changes as we age over time under these metabolic conditions. This conduction slowing is distinct from neuronal loss, representing a specific failure of signal insulation rather than a loss of cells in healthy adult populations to support cognitive endurance. Microglia are activated to clear damaged myelin debris, a process that can trigger low-grade, localized neuroinflammatory signaling pathways in white matter for long-term health span as we age over time. If this local inflammation persists, it can further impair oligodendrocyte function, creating a self-sustaining cycle of myelin degradation during daily cognitive tasks in healthy adult populations. Furthermore, insulin and VDR signaling pathways coordinate with oligodendrocytes to support the energy-intensive process of lipid synthesis to protect our brain structure for long-term health span. When these metabolic support pathways are compromised, the rate of myelin synthesis declines, accelerating the effects of white matter aging as we navigate healthy aging during daily cognitive tasks. The maintenance of rapid processing speed is closely dependent on the preservation of this lipid-rich insulation throughout our neural networks in our daily lives to protect our brain structure. We must examine the boundaries of this myelin model to understand how to support our cellular defenses through lifestyle protocols within neural tissues. By analyzing the limitations of current research, we can establish realistic expectations for cognitive support strategies as we navigate healthy aging under these metabolic conditions. One limitation of myelin research is that we cannot directly observe real-time conduction velocity changes in living human subjects to support cognitive endurance. We rely on indirect measures such as diffusion tensor imaging that estimates white matter tracks and cognitive processing speed tasks as we age over time. In clinical cohorts, individual rates of white matter changes vary widely due to genetic factors and lifetime vascular health profiles in healthy adult populations. We must also recognize that processing speed decline is not regulated solely by myelin, as synaptic density and neurotransmitters contribute for long-term health span. The population boundaries of current trials are narrow, and we lack standardized clinical methods to increase oligodendrocyte activity directly during daily cognitive tasks. Because we cannot directly measure microscopic sheath thickness in humans, we must interpret imaging and biomarker data with scientific caution to protect our brain structure. Therefore, we analyze myelin degradation as a key contributing pathway in processing speed decline, rather than a single diagnostic indicator as we navigate healthy aging. Answering our opening question, slower thinking is often a signal transmission issue related to myelin rather than a sign of forgetting in our daily lives. By understanding this physical mechanism, we can reframe our habits, focusing on supporting systemic metabolic health to protect our white matter within neural tissues. When myelin integrity is preserved, signal conduction remains rapid, supporting efficient network synchronization and cognitive speed during daily work under these metabolic conditions. The practical challenge is supporting oligodendrocyte health through low-risk daily habits, nutrition, and exercise as we age over time to support cognitive endurance. While we cannot prevent all age-related changes in oligodendrocytes, we can optimize the metabolic factors that influence myelin stability as we age over time. Consuming dietary lipids like omega-3 fatty acids is associated with improved membrane structure, which supports the physical composition of myelin sheaths in healthy adult populations. Regular physical exercise promotes cerebral blood flow, delivering the oxygen and nutrients required for energy-intensive myelin synthesis and repair for long-term health span. These metabolic habits do not change memory storage directly, but they support the structural pathways that keep signal transmission fast during daily cognitive tasks. Supporting myelin maintenance requires a unified focus on dietary consistency, regular movement, and proper sleep to optimize these cellular systems to protect our brain structure. To apply these insights, maintain a balanced diet rich in essential fatty acids to support the lipid composition of your brain as we navigate healthy aging. Engage in regular aerobic exercise to support healthy vascular function and promote optimal nutrient delivery to your white matter tracts in our daily lives. Prioritize quality sleep to facilitate the lymphatic clearance processes that help remove metabolic waste and support overall glial cell function within neural tissues. Consult a healthcare professional to monitor vascular biomarkers like blood pressure and cholesterol, as vascular health supports white matter integrity under these metabolic conditions. Avoid using unverified supplements that claim to rebuild myelin quickly, as clinical evidence supporting their efficacy in healthy adults is lacking to support cognitive endurance. Please remember that this analysis is intended for educational purposes and should not replace individualized clinical evaluation or specific medical advice as we age over time. Focus on establishing consistent, low-risk daily habits that support physical activity and reduce systemic metabolic stress naturally and safely in healthy adult populations. Track your daily exercise, dietary lipids, and cognitive processing speed to build a personalized, evidence-bounded framework that supports your long-term health span for long-term health span. Optimize the protocol, protect your brain, and I'll see you in the next data set.